First off, here's the test. And if you look at the front side, you can see that it's all problems, as you'd expect. They're going to be V2, P2, T2 problems. And I'm going to do a bunch of those on the board. The top one's a problem, but then the rest of it is questions. Multiple choice, short answer, fill in the blank kind of definition questions. All right? And that's quite a bit, more than I thought. Originally, I was saying about 20% or 15. I think it's more like 25 or even 30, maybe even up to a third of the test will be from the notes. Now, there aren't a whole lot of notes that are going to come from. They're going to come from these two areas right here, kinetic theory and properties. Right now, if I asked you what the 5 statements of the kinetic theory are, you couldn't tell them to me, I'm sure, okay, because you haven't looked them over. I can't help you with that. You're going to have to look that up tonight. I can help you with these problems. Also, when it comes to the kinetic theory and the properties of the gases, I may ask you to explain stuff or define stuff. It's not going to be real simple things. Somebody asked also about, will there be a question or so about what's the name of each law? Not a lot, but yes, you should know which one's Boyle's, which one's Charles' law. You should know which one's which. As I do each of these, I'll tell you which one's which. But I really want to spend some time on is going over these problems and showing you all the mistakes you probably will make, but something else. This class in particular missed, because of the band thing, missed quite a bit on Dalton's law. So these problems here, 3 and 4, I would like to spend a little bit more time on. 1 and 2, I plan on doing very quickly. Spend a little bit more time, especially on 4. All right, because that's one you will see like that. I want to like that on a test, and it's worth quite a few points. I don't want somebody to be so confused by seeing this collected over water stuff and never having seen that before, maybe because you're absent for 2 days, not knowing what to do. All right, so let's go over these, and we'll start with number 1 and 2. Okay, these won't take me very long. I plan on doing them, not like I said, I'm teaching it from the first time. You know how to do these. Write down V1 equals V2, P1, P2, whatever the variables are. This one, if I had to, I could write down T1 and T2, but they'd only have changes. This one only has changes in pressure and volume. All right, so I only need changes in volume and pressure written down to the side. Let's pick them out first and see what happens. V1, my initial volume is 40 milliliters. Everybody agree with that? My V2 is what it wants to be, what we're looking for. P1, initial pressure is what? 825 torr. And P2? 2.0 atmospheres. Now, got a couple of problems here. Actually, one problem for the pressure. I have atmospheres and torr. It doesn't matter which one I convert to what, but I will convert him to torr. 760 torr, 1 atmosphere. What do you get? Well, you get 1520. Well, what do you actually write down because it's significant figures?
Wow.
Right? Why? Well, because he only has 2 significant figures, right? If you convert it, then most people convert this one, I'm assuming. That's why I'm seeing a lot of people. If you converted that one, it should have had only 2 significant figures, right? Because he only has 2. This guy doesn't limit me. My 760 doesn't limit me, but this one does. All right. So is that right? Who didn't do this one? Did you get 1500, or did you write? So as long as you didn't write 1520. All right. Well, anyway, that's your first little thing. You may have to do some conversions between torr and atmospheres, millimeters of mercury. You may have to do that. Now, V2, P2. And I could have written, if it's all I needed, over T2 equals V1, P1 over T1. But I don't write it in there because I only have changes in V and P. I have to rearrange it. What am I going to do to both sides to get V2 by itself? I'm going to divide by P2. So V2 is going to equal V1, P1 over P2, which will be 40.0 milliliters times P1, which is 825 torr, over P2, which is 1500 torr. Now, one thing I find is a mistake, a very dumb mistake, and it doesn't cost you a whole lot of points, but it happens all the time. We go through the trouble of making conversions over here, and then when we go to read them and plug them into here, we just read the first number next to P2, which would be 2. You'll catch that if you keep your units. If you keep your units, you'll catch that. If you don't keep your units, you won't. Anyway, who got the answer for this guy? What did you get for V2 here? 22? Everybody get 22 milliliters? All right. I believe that is the answer we got last period as well. Is that good? All right. Next one I'll do even faster. Still show you some couple of changes here, though. Number 2 says it has a temperature and a volume. So we got V1, V2, T1, and T2. My volume, my initial volume, V1. What is that here? Well, 44 milliliters is going to be compressed, so it's 44.1 liters, I should say, not milliliters. V2 is compressed to 965 milliliters. T1, my initial temperature was minus 40. And my T2 is what it's looking to determine the new temperature. Very good. Now, I have to make a couple of changes here, too, a metric conversion and a temperature conversion. How do we do the temperature conversions? I hope by now you know. You just add 273, and I'll get 233 Kelvin. Is that right? And I hope you all know how to do a metric conversion since Chapter 2. You can convert it either way. This guy, when you convert it, is going to be 0.965 liters, right? All right. Now, my equation this time is, again, V2, P2 over T2, but all I care about are the T2s and V2s. V1, P1 over T1, so V1 over T1, right? What I would recommend for a guy like this, I told you tricks we could do to rearrange these kind of guys. We don't have to use the basic laws of algebra. We could take some shortcuts. I want to solve for T2. I would recommend cross multiplying. T2 V1 equals V2 T1, right? And then divide both sides by V1 to get T2 by himself. So T2 equals V2 T1 over V1. Now, I'm not going to plug the numbers in. I'll save myself a little bit of time so we can get through the rest of it. If you plug all those in correctly, this guy, and that guy, what do you get for your T2? Ellie, what'd you get? 5.09. Anybody else get that? 5.09? All right, and what are the units? Kelvin. Okay. So there you have it. That look good, everybody? Okay. And, you know, by the way, I did say you could do this as well, too. What happened to the volume? It went from 44 down to less than 1. It got decreased by a lot. How are volume and temperature related? They're directly proportional. I would expect the temperature to go down by a lot. It goes from 233. Yeah, makes sense. So I can also see if it makes sense at the end as well. So there's two ways you kind of check your answers. With the units, I didn't keep a minute for this one because we're trying to do it faster, and by whether it makes sense. If you have two changes at the same time, you won't be able to do that. If you have both volume and pressure and temperature all changing, can't really do that. But you can do it for just the simple ones. All right, now it's time to go over the ones that probably about a third of you missed when you weren't here for it, and that is Dalton's law. Dalton's law is real simple. It just says that a mixture of gases, total pressure is going to be equal to the sum of all the other guys' gases added up together. So if I've got a guy like this, basically the equation becomes this. P total equals PA plus PB plus PC plus etc. Okay? As many as you need. So what do I have here? I got a mixture of gases. Total pressure, it says P total, it tells you, is 1.86 atmospheres. It then tells you the pressure of the missing gas is what you're looking for. And we'll call him C. And so PA and PB, what do they give you? They say PA is 0.390 atmospheres, and PB is 300 torr. All right. What's the decimal there? And that's 3.390. Oh, 0.390. All right. I've got atmospheres and atmospheres, and I got a torr, so I'll convert the torr to atmospheres. When you do that, torr goes to the bottom, atmospheres on the top. 1 atmosphere contains 760 torr. What do I get for that? Who did that? 0.394? Let's get that. 0.394 atmospheres. All right, now here's what I'm saying. You're basically, you're told your total, and you're told what PA and PB are, and you're looking for PC. This is a mixture of 3 gases. So we're looking for PC, right? What do I have to do? If I plug this in, what am I going to do rearranging the equation? I'm looking for PC. I'm going to subtract away PA and PB. So PC is going to equal P total minus PA plus PB. Making sure you do that in the parentheses first, right? You see what I'm saying? Make sense? Right? Look, it's very simple. If A plus B plus C equals the total, and you know A and B, and you're looking for C, you're just going to subtract them away, right? All right, now I know you weren't here, but it shouldn't be that hard. If you plug all those numbers in, what do you get for that? Who got it?
1.08.
How much?
1.08.
Anybody else get that? 1.08? Look good? All right. Now, I said I'd do this one because I didn't do this in your class. Not as many people. I had a lot more people absent in this one. And plus, they didn't have the time. But really, where this becomes important, again, something that you guys missed, you missed the lab. on Dalton's Law, those of you who were absent that day. And that lab on Dalton's Law, the reason this is important, when I collect the gas by bubbling it through water, I have two gases. I have the gas I was collecting plus water vapor. And that's why I just passed out to you guys these water vapor pressure charts. Okay, you're going to use these on the test tomorrow as well. All right, so let me show you how you would use that in a problem like this last one. We have just enough time to do, well, more than enough time really to do this one. Okay, this last one looks like a normal question. Oh, by the way, I just realized I didn't recopy it, did I? I didn't put the changes in there. Hold on. Here's what the question looks like. "350 milliliters of a gas collected over water at 25 degrees has a pressure of 832 millimeters of mercury. What volume will the gas occupy at STP?" Okay. Now let me, so we can look at it. We'll do it on this page right here. V1, V2, P1, P2, T1, T2. Okay. Those are my variables. I have all 6 variables, and I have other changes to make along the way as well. My initial volume, let's read the question. Initial volume is 350. Everybody agree? My V2, it wants to know what will the new volume be? What volume will it occupy? That's the unknown. P1, my initial pressure appears to be 832 millimeters of mercury, but it is not. This is the new thing. You guys who were here saw us do this in both the lab and in the notes. But here it is. That is the pressure of the water and the gas you were collecting. All right? Because it says it was collected over water. I want the pressure of the dry gas at the end. So I need to subtract away the water vapor pressure. How do I know which water vapor pressure to use? Well, it depends on what the temperature is. This guy's temperature was 25 degrees Celsius. I look on my chart. You guys who weren't here, look on your chart for 25 degrees Celsius. It tells you the pressure is 23.76. Everybody see that? So minus 23.76 millimeters of mercury. Got it? What did you get for that? All right, well, remember, significant figures for adding and subtracting are just going to be like subtracting 24. So 24 from 832 would be what? 808. 808, is that right? Millimeters of mercury? Is that correct, I think? All right. Now, P2, another problem with this guy. This is something you guys were here for. It wants to know what will the new volume be at STP. It doesn't give you the new volume. It just says at STP. STP stands for standard temperature and pressure. Standard pressure is 760 millimeters of mercury, which does not limit my significant figures because the 760 is my standard. All right. My initial temperature, let's look at the question again. Initial temperature was 25. I can't use that. 25 degrees Celsius, I have to add 273 onto that, get 298 Kelvin. And my T2 is standard temperature pressure. 273 is standard temperature, okay, in Kelvin. All right, that's a lot of stuff to do. Look what we had to do here in this one. We had to subtract away the water vapor pressure. All right, we had to convert Celsius to Kelvin. We have all 6 variables. All right, now it's time to do the equation. V2, P2 over T2 equals V1, P1 over T1. Right? I have all of them used this time. What am I going to do to both sides? Multiply by what? T1 over P2. You see why? T2 over P2, right? You see why? Because T2 will cancel and P2 will cancel. You multiply both sides by that. All right, I don't have room because I'm actually running out of room here. It won't fit. But basically, I'll get V2 equals V1, P1, T2 over T1, P2. That look good? Did you all do that who were here? Hopefully. I don't have room, obviously, again, to plug my numbers in, but what will I get to put for my final answer here? Anybody who did all that? What did you get? What did you get?
340 milliliters.
You got 340? Anybody else get that? Yeah? A couple? Quite a few? Okay. 340 milliliters would be the final answer then. All right? So the way Dalton's law affects my questions in the test, and they're going to affect our next 2 labs we do too, is that collected over water word. Where it says that, I got to subtract away the water vapor pressure using that chart from the pressure it actually gives me. All right, now, last thing before we finish up, just one more time, I should mention, these 2 guys are, I'm telling you, most of your points are going to come off of that page. The page is about a third of the test. You're going to lose most of your points because you won't study the kinetic theory. You don't know it right now. Even on the properties of gases, there's a whole bunch of properties of gases we talked about, and you need to understand them and be able to explain them or define some of them. So it's a page and a half of notes of new actual terminology. This stuff you'll do fine on, especially if you were here today. And there's nobody else in here, right? So you'll do fine on this. It's this stuff you're going to lose most of your points from if you don't study.